So today we're going to talk about rationalizing the denominator. So what rationalizing the denominator is if we had an expression like 3 divided by the square root of 5 or 3 divided by 2 minus the square root of 5, then rationalizing the denominator would be a process in which we remove this root from the denominator. Usually when we are working with roots, we want roots to only be in the numerators. Unfortunately, because of the properties of roots, it's quite simple for us to change the location of this root by doing a simple bit of algebra. It involves multiplying by 1 effectively a lot. So we have two cases. This is case 1. Case 1 happens when you have a number and it's just divided by a root, whereas in this case we have a number divided by another number which is added or subtracted to a root. So let's take a look at this case first. To rationalize the denominator here, we're going to multiply this number by the square root of 5 divided by the square root of 5. Now you might be wondering why I'm allowed to do that all of a sudden. Well, the reason is the square root of 5 divided by the square root of 5 is equal to 1, and I can multiply any number by 1. So it turns out that when I multiply 3 divided by the square root of 5 by the square root of 5 divided by the square root of 5, this does not actually change the value of this number in the slightest. So I'm allowed to do that, but let's see what happens. So it might be tempting to try and cancel here, but you don't want to do that because we're intentionally doing this to look at what's going to happen to the denominator and numerator. So don't cancel in this case. So we're going to multiply the numerator, so 3 square root 5 is going to be the numerator, and square root 5 times square root 5 is 5. So look at that. We managed to rationalize the denominator by multiplying by square root 5 over square root 5. And this one's a little bit more complicated. We can't just multiply it by the square root of 5. Instead, what we're going to do is we're going to multiply it by 2 plus square root 5 divided by 2 plus square root 5. This is called the conjugate of this number. So let's see what happens when we multiply that out. So here we'll have 3 times 2 is 6, plus 3 times square root 5 is 3 square root 5. Let's see what happens down here. 2 times 2 is 4. 2 times square root 5 is 2 square root 5. Negative square root 5 times 2 is minus 2 square root 5. And then square root 5 times square root 5 with a negative is minus 5, which will simplify to 6 plus 3 square root 5 divided by 4 minus 5, which will become 6 plus 3 square root 5 divided by 1, and then I'm going to put the negative up here. So that would be my final answer. So if you have a number which does not have another number added to the root in the denominator, you don't need to worry about using the conjugate, but here you do. So the idea of a conjugate is if you have a plus b times square root c, then its conjugate is a minus b square root c. That's the definition of a conjugate, but for now just try and remember that process. Now let's look at 3 example problems. For our first example problem, let's take a look at square root 10 divided by square root 3. We want to rationalize the denominator. So this one does not have anything added or subtracted to the root here, so we don't have to worry about using conjugates. So all we have to do is multiply by square root 3 divided by square root 3, which will give me square root 3 times 10 is square root 3 times square root 10. And then square root 3 times square root 3 is 3. And let's make that look a little bit nicer. Using the product property, you can do 3 times 10 and take the square root of that divided by 3, which will become square root 30 divided by 3. And that's my final answer. For our second one, let's take a look at 8 divided by 1 plus square root 3. Now this one, since we're adding this 1 to our root, we know that we're going to have to use the complex conjugates. So here we're going to multiply the top and bottom by 1 minus square root 3, divided by 1 minus square root 3, once again we recognize that this is really just the number 1 in disguise. And so 8 divided by 1 plus square root 3 times 1 is still the same thing, we're just changing how it looks a little bit. So now I'm going to multiply the numerators, so I have to distribute the 8. So 8 times 1 is 8, minus 8 times square root 3 is 8 square root 3. The denominators, 1 times 1 is 1. 1 minus square root 3 is square root 3. Square root 3 times 1 is plus square root 3. And then square root 3 times negative square root 3 is minus 3. So this will become 8 minus 8 square root 3. These are going to cancel out. And 1 minus 3 is negative 2. And then I'm going to choose to move the negative sign to the numerator because I think it is more appropriate to have the negative sign in the numerator. It doesn't actually matter, but it's conventional. And then I'm going to distribute to get negative 8 plus 8 square root 3 over 2. And then I'm going to notice that I could actually simplify this further if I factored out a 2, and I would get 2 times negative 4 plus 4 square root 3 over 2. The 2's are going to cancel, and I would get negative 4 plus 4 square root 3. And that would be my final answer. But what I'm really looking for here is that you know how to you do rationalization. So this is the main thing I'm looking for. But if we kept continuing through and got to here, that's awesome. Finally, let's take a look at square root 13 divided by square root 5 minus 2. What we're going to do here is once again multiply by the complex conjugate. One thing to note here is that here on the left we have a square root, and on the right we have the term that doesn't have a square root. Usually we've been seeing it moved around. However, it's important for us to change the sign of the term with the root in it and not the term that doesn't have a root when we're doing complex conjugates. So it being flipped around, we have to account for that. So we're going to multiply this by negative square root 5 minus 2 divided by negative square root 5 minus 2. So let's see the top. We're going to have negative square root 5 times negative 13, so negative square root 5 times square root 13, and then it's going to be minus 2 times square root 13, and on the bottom, negative square root 5 times square root 5 is negative 5, square root 5 minus 2 is minus 2 square root 5, negative 2 times negative square root 5 is plus 2 square root 5, and then minus 2 times minus 2 is plus 4. So this is going to become negative square root 5 times square root 13 minus 2 times square root 13. These are going to cancel. And then negative 5 plus 4 is negative 1. Now I notice here that all these minus signs, I can factor them out in the top to get negative square root 5 times square root 13 plus 2 times square root 13 divided by negative 1. So these negative 1's are going to cancel, and I'm going to be having square root 5 times square root 13 plus 2 times square root 13, and then I could simplify it with my product rule to do 5 times 13, which is square root 65. And I knew this really quickly because 5 times 10 is 50, and then I have to add 5 times 3, which is 15, so that's 65. And then plus 2 square root 13. And that would be my final answer. Once again, getting to this point is really the main thing I care